Yeah, perfect, guys. And I started the recording. And once again, thank you, people who have joined. Yeah, I could see now presently 75 members are online. Yeah, that's really good. Yeah, let's quickly get into the session. Yeah, before starting the session, right, I'll give a small brief about myself. Most of you guys are already familiar with me. Many of them repeatedly attending the sessions. So yeah, very few people know, very new. Coming to the point, myself, Hari, I'm working as a senior cloud consultant. Currently, right, I'm taking care of AWS, Azure, GCP, and DevOps, and this all Kubernetes, everything. I'm having around 12 plus years of experience. Okay. With respect to a high tech institution, right? Yeah, from the high tech institution only, I'm taking care of this training and all. Past 8 to 9 years. Parallelly, I'm working as a senior cloud consultant, and meantime, I'm taking this training and all. Okay, that way, I'm handling both the things. Okay, then only I can be a updated person. All right. So fine. From our high tech institution, we are starting this Kubernetes batch. This is going to be our 63rd batch in Kubernetes. But anyway, that's different story. But before starting this technical discussion, right, many of them from our WhatsApp group, right, they pinged me individually, they called me. Sorry, for very few people, right, I couldn't answer them. I'll tell you what, they're repeatedly asking the same frequent questions. So first I'll address their frequent question. After that, I'll get into the technical portion. Yeah, their frequent question is all about, hey Hari, when are you gonna start this batch, and what is the duration of the course, and how much is the fee structure for your training, and what are the topic you're going to take, and what are the projects you're going to show me. These are the questions, and what is the timing, and what is the duration of your entire batch of Kubernetes, whether you include Docker. So these are the frequent questions, right? They asked for. I'll just answer them, then we'll get into the session today. Yeah, this Kubernetes, right? I'm not directly going to start from Kubernetes. Obviously, I'll be starting from the Docker only. First, I'll give the introduction to Docker. First 1 week of session going to be Docker. Then only I'll be get into Kubernetes. So the whole batch, right? Docker plus Kubernetes whole together, I am planning to take care for 1 month of course. Okay, the course will be on Monday to Friday. Saturday, Sunday will be holiday. The course will be the 1 month of course will be Monday to Friday only. Saturday, Sunday will be holiday. You can practice it. I'll be giving you task. You'll have to practice on Saturday and Sunday. You have to come up with the output by Monday. That is the action plan. Okay, so remaining regarding about the topics, what are the projects we're going to cover, everything I'll show you. And with respect to one fee structure, right, I'll show you what are the fee structure for this entire batch. I'll tell you, and other what are the offers is available. Every information I'll show you before end of the session. Okay, now we'll quickly get into Kubernetes. All right, so people are waiting to learn the new technology, and grooming technology all knows the importance of Kubernetes. So one beauty about Kubernetes, right? So people, they may be from any technology. Currently, you may be working in AWS cloud admin, or currently you may be working as Azure cloud team, or you are currently working as a GCP team, or you are working as a DevOps guy, whatever, or you are working as a developer, whatever role you may be currently in, Kubernetes is common for all the peoples. Kubernetes is the common for all the peoples. Everybody can learn Kubernetes, because future is completely depends on containerized microservices kind of thing. So Kubernetes is one of the wonderful tool and open source tool which supports everything. So that is the reason I'm telling, whatever experience you may have presently doesn't have any problem. Whatever technology you're having working presently, it's not make any problem. Kubernetes is common for everyone. Okay, that is the uniqueness and and the uniformity that is available with Kubernetes. Okay, fine. Let's quickly we get into this, and I'll give you one note before starting it. This complete 1 month of batch, right, Docker plus Kubernetes is all together taken care by myself only. No other trainers going to involve. The entire session, right, will be handled by myself. I'll be your batch owner. I'll be your central point of contact. Okay, that's good. We'll quickly get into the session. Before starting Kubernetes, I want your input as well. Anyone from the crowd can unmute and answer. What is your understanding about Kubernetes? Let's see how far you have understanding. Anyone can tell me. Anyone can answer it. What is Kubernetes from your perspective?
Container orchestration orchestration tool.
Very good. It's container orchestration tool. Okay.
And yeah, each network of it, each container is isolated. I mean, it can manage by using this particular tool.
Very good. Very good. Thank you, Sujin. So it's very good input, actually. Very useful. Yeah, whatever he said, right? It's absolutely perfect. But what I would like to do, right, before discussing Kubernetes, I want to discuss the history, past. what's there before the Kubernetes coming to the picture. That I wanted to discuss. I'm very much eager to discuss about that that particular part. Okay, so I'll tell you about. So before that, right, before Kubernetes coming to the picture, there is an individual. We'll start from the beginning. If you take on-premises data center, we'll have a server. If I want to host any application, it can be a web application or customized application, whatever it is, I need the physical hardware, physical server. On top of the physical server, I'll be deploying all my application. Later, people are realized, hey, oh my God, in order to deploy all the application, I need individual physical server. It will cost you a lot. It's consuming lots of spaces, management, maintenance, everything all together. It's a problem. So that is the reason no people are come up with. There is a concept called hypervisor concept. There is a concept of hypervisor. When people are coming to hypervisor concept, right, virtual machines plays a major role actually. What they did, they will have a single hardware actually. They will have a single hardware like this. They will have a CPU, they will have a RAM, they will have a storage, everything. They are calling it as a hardware. On top of the hardware, they will be installing, there is something called hypervisor. On top of the hardware, they will be installing something like hypervisor. On top of the hypervisor, they used to create a virtual machines like this. They used to create a virtual machines like that. The advantage about the virtual machine, right? Earlier, for each application, they had each physical server. Later, what they did, they divided a physical server into multiple VMs. They have divided the physical hardware into multiple VMs. So, approximate, right? We can tell you for just our understanding, in single hardware, we'll be provisioning 5 to 10 virtual machine. We can host the 5 to 10 different application into my virtual machine. It will provide you the isolated environment to run our application. This is something called it as a hypervisor architecture. There are many vendor, like I can tell you VMware, EXXI, and we have Microsoft, right? They had a Hyper-V hypervisor. Linux, we have a KMS, like that, right? We have a many hypervisor vendors are there. They helped us to provision multiple virtual machine. Okay, they helped us to provision multiple virtual machine on top of the hardware. All right, so that's how VM got famous. And later, right, even people are felt that is something difficult in terms of managing our virtual machine, because virtual machines are by default, they are consuming lots of hardware actually. Okay, so if you take a VM number 1, VM number 2, VM number 3, they will be individually consuming lots of hardware actually. Even though if I'm going to provision small scale application, I need to provision the whole operating system. So when I'm comparing the small application, it really required this much capability of this much capability of specific utilized hardware. It's not really required. That is the reason from the virtual machine, right, people are migrated into container based technology. From the virtual machine concept, people know they later moved to container based technology. Container based technology means it's almost working principle similar like my virtual machine only. See, I'll tell you the architecture of the containers. So when you take a hardware, same CPU, memory, RAM, everything will be there. On top of it, you will install, there is something called operating system. Here what happened, instead of hypervisor, they install the operating system. Operating system 99.99% it will be Linux, Unix based operating system. It can be Ubuntu, it can be CentOS, it can be RHEL, any one of this operating system it should be. On top of the operating system, right, people were installed, there is something called Docker engine. There is something called container engine. Container means there are many container providers are there. See, in hypervisor we discussed, right, we have something called VMware, ESXi, we have something called Windows Hyper-V. Similar way, Docker engine, right, it's been provided by multiple people. Sorry, container engine that's been provided by multiple people. Hope you have heard about Docker and all. Okay, I'm not able to write it properly, but somehow adjust. Okay, adjust with me. So okay, there are many container engines are there. One most of the people mostly familiarized to use, which is Docker. Okay, it's one of the, in reality, maximum in every project people are used to go with this Docker based container engine. Some other people are there, RKT container engine, Rocket container engine. Similar way, we have many container engineers are available. But anyway, you understand in such a way, on top of the operating system, we have a container engine or Docker engine available. On top of the Docker engine, right, people will be installing the container. These are my container number 1. Okay, this is my container number 2. This is my container number 3. Okay, so on top of hypervisor, initially we had a VM, right? On top of hypervisor, initially we had VM, right? But on top of container engine, I mean Docker engine, we have the multiple containers. What is the difference between containers and virtual machine? What is the difference between container and VMs? Containers are creating on top of Docker engine. Virtual machines are creating on top of hypervisors. Correct, that is the difference. So coming to container, so it's not consuming lots of hardware resources like my virtual machine. Containers are basically very lightweight by default. It's very much flexible. See, I can tell you, in fact, if you take a same hardware, if you take a same configuration of hardware, two hardware you are having identical, both are having same CPU configuration, both are having same RAM configuration, storage configuration, everything ditto identical. So in server number one, if you provision hypervisor, if you are creating virtual machine, in server number two, you are creating Docker engine, you are creating multiple containers. Obviously, you will be able to provision more container on server number two, and more you can deploy more number of application on server number two. The reason behind Docker and containers by default, by naturally, right, will consume very less hardware. The reason behind why they are consuming very less hardware, containers doesn't have any kernel. Okay, hope you guys heard about kernel. Kernel is the component. Anyone knows what is kernel? Anyone want to give your input? What is kernel?
What?
All right, no issues. I'll tell you. No problem, guys. Maybe. Yeah, kernel is the
Next platform we have, right, kernel.
heart of your operating system, we can say. Okay, the kernel actually what it does, it's the interface between your hardware and your operating system. Actually, operating system completely made up of your application, program, software component, right? But hardware is totally a electronic component actually. So the kernel used to work as an interface between your hardware and operating system. So basically coming to Docker concept, right, in this technology, each of every container, so this is our container. Each and every container will not have your kernel. Whenever they need kernel related help, right, they will reach out to your base operating system. It will provide the kernel related functionality. Even you are deploying 10 containers on top of Docker, even you are deploying 20 containers on top of Docker, no problem at all. Your base operating system will help them to provide a kernel related activity. Okay, that is how Docker made containers are by default. It's very light in size. We'll be able to host more number of container in the given hardware. Okay, so that is the reason people are started using, after virtual machine, people are started using container. One another reason, those are totally open source. We don't want to pay to anyone. But where in VMware workstation, sorry, VMware ESXi and Hyper-V and all, it's very huge in cost actually. So they are billing, right, their product product activation key, right, it's very huge in cost. So that is the reason people are stopped using that specific thing, and people are started using containers. Okay, so things are going on well, but later, right, people realized when come to Docker based container engine technology like this, there is no high availability there is no proper high availability. For example, if this operating system goes goes down, or the server hardware goes down, there is no point in keeping our container on top of it, though those will also go down actually. If any of your container architecture operating system goes failure, or your base hardware goes failure, whatever reason it may be, your individual container also will go down. We won't be able to recover it. So that is the reason people felt there is a huge drawback of container. So later they realized and they have changed their concept, which is Kubernetes. That is the reason people are started coming to Kubernetes. Yeah, before Kubernetes, we have something in place. There is something called Docker Swarm. Okay, so after Docker containers, okay, after Docker container, we have one more thing, something called Docker Swarm, which also providing you high availability. But people, right, in reality, if you go more, people are started using Kubernetes, because the reason I'll tell you, Kubernetes is the product of Google actually. Earlier, Google has been found and introduced this particular tool. Okay, what happened? Google, to provide service to their visitors and Google's customer, they have developed this particular technology, something called Kubernetes. Later, right, they released that as an open source. Once they made it as an open source, what people does something like cloud service provider, something like Amazon Web Service, something like Microsoft Azure, something like Google Cloud platform. What the people does, right? They made Kubernetes as one of the service on their cloud platform. What they did, they made Kubernetes one of the servers on top of their particular cloud platform. Once it became cloud service, right? Later it became cloud service. Kubernetes, right, started being used by many people. Okay, even earlier so many people were using on-premises based Kubernetes. I mean, all the server, right, everything will be managed by the on-prem server on top of it, right? They will configure the Kubernetes and everything. But later, right, it's become everything into virtualized. In people now started using Kubernetes on top of cloud service provider. Okay, first you understand the structure of and the architecture of Kubernetes. Later you will understand everything. As of now, hope you have a very good awareness of how hypervisor are working, how containerization Docker things are working. Now you're going to understand the Kubernetes architecture. Okay. When talking about Kubernetes, people are giving more priority to high availability. What does mean by high availability? Anyone answer this question? What is high availability?
Our website should not go down.
Yeah, very good. Something when you may not only website, any of the service rate will not go down. Even if that goes down, there will be another one resource will be available as a backup. So literally I'll have a two server. If one server goes down, another one server, right, will be ready to provide me a support. So end of the day, my customers will not face any downtime, correct? That is something called high availability. Coming to Kubernetes architecture, right? Coming to Kubernetes architecture, the first priority what they are giving is high availability. HA is their more concentrated one. Whatever client coming and using Kubernetes, whatever application they are deploying on top of Kubernetes, they are very much ensured their application is running on high availability platform. So since they are providing high availability, right, they are coming into the concept called clustering. Okay, people always used to call it as a Kubernetes as a cluster only. So mostly people will not go with Kubernetes as a single node. When talk about cluster, right, there will be multiple nodes will be there. Node 1, node 2, node 3, node 4, like that. In the example, whatever you are seeing, right, you can see there are 3 nodes. This is my node number 1. This is the node number 2. This is my node number 3. So in the example currently, I'm going to explain the Kubernetes architecture with the 3-node cluster example basis. Okay. So based upon your applications requirement, based upon your project requirement, based upon your customer need in your project, right? The 3-node cluster may change into 4-node cluster, 5-node cluster, 10-node cluster. It's totally up to you and your project requirement only. Okay. As of now, understand the 3-node cluster structure. Same thing will work for even 10-node cluster also. Same working principle applies for all the node of cluster. So talking about cluster, the main reason people are coming to cluster is if one node goes failure, another one is ready to available for providing service. Okay, that is the main point. The people why they are coming to cloud-based Kubernetes. I told you right, initially people were using on-premises based Kubernetes service only, but present today in reality, almost all the people, right, started migrating their on-premises based cluster into cloud-based Kubernetes cluster. I mean, your Kubernetes cluster are present on top of AWS or Azure or GCP. I'll tell you the reason why. If any one node goes failure, for example, this particular node goes failure, node 3 goes failure. Okay, understand? If node 3 goes failure, what your cloud provider will do, there is something concept called auto scaling. It will recreate the node behalf of you. There is no manual intervention is needed. There is no manual intervention is needed. For what your cloud service provider will do, there is a concept called auto scaling. When your node 2 or node 3 or node 1 goes failure, with the help of auto scaling, it is automatically reprovisioning a one number of node, which is automatically adding into your Kubernetes cluster. End of the day, right, my customer will not face any issue in the backend. That is the advantage. Wherein if you compare the Kubernetes and on-premises, right, if any one node goes failure, you need to take manual responsibility to replace the particular node. That is the maximum. That is one of the reason people are started using cloud-based Kubernetes service. Okay, cloud-based Kubernetes cluster. That is the first reason. We have one more reason also. I'll tell you after understanding the Kubernetes architecture. So when talking about Kubernetes architecture, right, we have a majorly 2 components. One is master node, another one is worker node. If you take any Kubernetes cluster, even if it is go for on-prem base, even if it is go for cloud base, there are 2 major components of cluster available. One is master node. In the Kubernetes cluster, some 2 major components. The node itself calling in the 2 names actually. We have a 5-node cluster, 10-node cluster, right? The node itself, they are calling it as a 2 major thing. One is master node, another one is worker node. I'll tell you, if you take a project, obviously we are all working in IT, right? If you take any project, there will be a project manager will be there, correct? What the role of project manager? He'll have to take care of my entire employees who are working on the specific project. For example, this person is doing this particular job. We'll assign this work to him. We'll assign this particular work to him. So whenever clients give any requirement, it will be initially come to a project manager only. If there is any escalation, right, initially the notification will come to project manager only. The project manager will be handling all the employees in the team, or the team member, they wanted to convey anything, they will go through the project manager only. Correct. So the master node is working like a manager for my entire cluster. The master node, the operations of the master node is going to be, it is the manager for my entire Kubernetes cluster. The master node will take care. The master node takes responsibility to maintain my cluster. All the applications are up and running properly without any issues. So I'll tell you. See, when a developer, who's the developer? You and me is the developer, the engineer, either Kubernetes administrator or Kubernetes developer, or you and me is the presently who will be interacting with the Kubernetes cluster. End of the day, you and me going to interact with the Kubernetes cluster, right? So we are the developer actually. When I want to interact with my Kubernetes cluster, initially my request will go to, I'll be using, there is a command line tool called kubectl. Okay, I'll use the command line tool called kubectl. Through that command line only, I'll be able to interact with my Kubernetes cluster. So as a developer, you and me is the developer. When I want to interact with the Kubernetes cluster, right, I'll be interacting through API server. In the master node only, I'll be able to interact with it. The master node will have a 4 component. First component is API server. Second component is etcd. Third component is controller. Fourth component is scheduler. Like that, we have 4 different components are available. So whenever I wanted to interact with the Kubernetes cluster, my request will initially go to this API server only. The API server which present inside of my master node, this is the entry point to my Kubernetes cluster. I don't have any other entry point. I supposed to, if I want to provision any application, I want to deploy something, I want to delete something, I want to remove something, I want to extend something, whatever, that is the only way which I can interact to my Kubernetes cluster, which is API server. So when I am interacting through my API server, right, this is the roles and responsibility of API server. It's the entry point my Kubernetes cluster. Second thing, etcd. Etcd, it's working as a brain kind of thing. Okay, etcd is the small storage which present in master node. It's a brain kind of thing. It will take care of the entire Kubernetes applications and configuration and the metadata about the entire cluster. Okay, it's the brain of my all my configuration, and all these information will store under this etcd only. etcd people used to call. Third one is controller. Controller will make sure all the nodes are running properly. If any one node goes failure, how can we replace it? And it will maintain all the nodes are up and running. My entire Kubernetes 5-node cluster I have been configured. This will make sure all the 5 nodes are working properly or not. That information will present on the controller part. And fourth component, there is something called scheduler. When I want to deploy some application, right, scheduler will know what is the utilization of the node 1. I mean worker node 1. What is the utilization of worker node 2? What is the utilization of worker node 3? To whom I can assign this application? I'll be controlling the load among in my the scheduler, right, will control the node backend behind the screen. In the node, it will distribute the work equally to all the nodes backend, and it will make sure all of them utilizing the same bandwidth. Okay, that kind of activity scheduler will be taking care of, and it will distribute the work in the backend. This all 4 major components present in this master node. All these 4 components are present in the master node. Ideally, the master node will not going to work anything. End of the day, manager is the manager of the cluster. He will not going to work. Actually, the person who working in the backend, who holding my customer's application, who exposing my application to outside the world, everything is worker node only. Everything present in the worker node only. This is one of the worker node. This is second worker node. If you take any cluster, right, minimum number of master node will be there, maximum number of worker node will be there. Okay, worker node again, it has 4 components. This is the component number 1. Kubelet, this is the container runtime. This is the second component. This is a network proxy. That is the third component. And pod, this is the 4th component. Okay, similar way, how master node has 4 components, even worker node has a 4 component working inside of it. I'll tell you what is the working principle of it. If you take worker node, right, Kubelet is the first person which has is the entry point for my worker node. Whenever I'm reaching to API server, right, in master node can communicate with my worker node through this kubelet only. We can see in the architecture diagram, from the API server only it's coming to kubelet. From this API server only this kubelet is coming to the picture. Correct? All these things are connected with my API server. When I want to host any application, when I want to do some operation, my master server will communicate to worker node through this kubelet only. Kubelet is the entry and exit point for my worker node. Okay, and container runtime. Here only I'll be installing my Docker. Earlier in last previous slide, you could be able to see only one server present. On top of it, we have installed Docker runtime, right? Here, multiple worker nodes are there. Every worker node, we are installing Docker runtime. Okay. So it's not only about Docker runtime. Here you can install anything. I told you, right? Many other container engines are available. Something like RKT, Rocket, any Docker engine you can install it. But in reality, in production, maximum number of people are using Docker based only. Even in our batch, we are going to see Docker based Kubernetes cluster only. Okay, it's a network proxy for exposing my application. Network related component will be taken by a network proxy. Pod is actually a place where I can deploy my application, See, initially hypervisor has virtual machine. See, I'll tell you with an example. Okay, initially my hypervisor has virtual machine VM. My Docker has containers. My Kubernetes has pods. On top of the pod only, I'll be deploying my application. Yeah, obviously, when you take pod, right, backend, there is a containers available. That and all, that is the behind the screen actually. Okay, we'll be discussing about that maybe in our session. We have a dedicated session for pod itself. We'll discuss about it. Okay, future classes. But as of now, in present, understand initially physical server were there. If you take a physical server, we'll be directly installing the applications. Applications are directly getting installed on the physical server. Later we realize this is a very huge of investment and the maintenance is really difficult. Later people introduced the hypervisor. In the hypervisor, what we did, we have single hardware. We have created multiple virtual machine with the help of hypervisor. That is, these are the virtual machine. On top of the virtual machine only, we'll be deploying our applications. Correct. Later we introduced Docker because hypervisor felt very expensive. They have introduced the Docker. That is the concept. On top of the Docker only, we have a container. On top of the container, we introduced deploying the application actually. Okay, here the huge change is hypervisor has its own kernel. Container, Docker container doesn't have the kernel. With the help of hypervisor, we created VM. With the help of Docker, we created a containers. Presently in Kubernetes, we have pod. On top of the pod only, we'll be installing our applications. This is the generation improvements actually. Okay, this is the difference. You have to understand it. Fine. So this is the reason, guys. If one node goes failure, another node will be provisioning. That is what my Kubernetes does. That is how it's providing high availability. So if one node goes failure, whatever parts and application running in the another worker node, it will transfer it over here. Initially, I told you, right, why nowadays people are started migrating on-premises Kubernetes to cloud-based Kubernetes. The first reason I told you, there is a functionality called auto-scaling available in cloud, which is not there in on-premises. And one more thing you wanted to understand, when you are using cloud-based Kubernetes, right, the entire master node functionality, right, will be taken care by your cloud provider. You don't want to worry about your master node. This master node has been completely taken by your cloud service provider. Got it? So that's more simple, right? We reduced our headache actually. We have to focus only on how many nodes, worker node you want, 1 node or 2 node or 3 node. Based upon your application requirement, you can go with that. So master node providing high availability to master node, just making sure all the configurations are up and safe in the master node. Everything will be taken care by your cloud service provider. This is the second reason why people are migrating from on-premises Kubernetes to cloud-based Kubernetes. Nowadays, if you go for attending any interviews, nowadays you are working for any customers who newly trying to deploy the Kubernetes cluster, everybody 90% prefer to go with the cloud-based Kubernetes cluster only because of these two reasons. In interview, if you go and tell them if you are managing on-prem based Kubernetes, that's something they felt like there is outdated technology. Cloud-based Kubernetes are playing a major role in present market. Okay, that's fine. Hope you have a very good understanding. Now what I'll do, I'll just move on to my next slide. Okay, so now the people, right, whoever working in different platforms, as I informed initially, you may be working as a AWS engineer or Azure engineer or GCP engineer, or working as a DevOps guy or application developer or tester, whatever. Kubernetes is common for everyone. Okay, nowadays if you go for any interview in any company, nowadays in job requirement itself, job description itself, or in the interview itself, people are started asking Kubernetes based questions frequently. It will give you the more benefits. Whatever technology you are in, if you are adding Kubernetes related content into your profile, it will be really helpful for everyone to attend the interview and clear the interview. That is the one thing. That is the reason you are seeing all these things. Okay, but one thing I wanted to see, the people know they are completely dependent on YouTube and Udemy. Hey, if I learn Kubernetes from YouTube and Udemy, I'll be able to clear it, right? In very free of cost, I can get Udemy from content from YouTube. But then why I need to pay for the course and I need to learn? The thing, right? Many of them thinking like that only, but there is a drawback available. I'll tell you the drawback now. So if you completely depend on YouTube and Udemy, right, the people that they are more and more into theoretical oriented. At least from this point, you start thinking from my perspective. I'll tell you one perspective of mine, which is if you take any YouTube people, or if you take any Udemy people, right, they will never ever share any information about the live Kubernetes scenarios. What are the client requirement? What kind of different deployment requirement will come into the Kubernetes project? What are the different issues we will face in the Kubernetes project? How these client requirement got fulfilled? What kind of different tickets we are receiving on the Kubernetes? What are the recent issue we faced? How are we providing RCA to my client? How secure we are managing our Kubernetes cluster and infrastructure? These kind of real project based. What is the roles and responsibility for the Kubernetes engineer? So these kind of these kind of real project based ideas, real project based scenarios is nobody will share it. Even if you take YouTubers or Udemy, whoever, if you take, nobody will be sharing these kind of information. So when you wanted to learn Kubernetes kind of thing, right, you have to go with the real project scenario basis, real time project basis. That real time project based use cases, right, that's really important for you. The real time project based scenario, right, that'll be really important to you. So learn from that perspective, gain the knowledge from that perspective. Some people will ask me, Hari, I'm very new to Kubernetes. That is why I joined your batch currently. That is why I'm attending your session now. How come you are asking me to go and learn the real project use case? How it will be practically possible for me? Okay, I do understand your situation. I do understand your concern. That is why I'm sitting in front of you. What I did, right, the people are asking such question. I have two documents with me. I'll show you my documents. This is my document number 1. And I have one more document also. I'll show you my other document where it is. Yeah, this is my document number 2. Totally, I have 2 documents with me. What, Hari? I have plenty of documents available with me. What is the special in this? But I don't have a time to go through all these. So you are also going to share one of the documents similar like that. It's not like such kind of thing. This document almost took almost 2 months of time to prepare us. I'll tell you why. So basis of our project knowledge, based on our project experience of 12 years, what we did, right? Yeah, overall experience, not only Kubernetes. Okay, based of that overall experience, we have created this document with complete client requirement basis. In this document, right, we are only going to talk about the real project Kubernetes scenarios. Okay, I'll tell you one. You will understand first. Say I'm starting with the Docker container, because in this training, right, I'm starting with the Docker only. First 4 to 5, 1 week of session will be Docker. We'll have to understand the Docker scenario. Practically, I'm going to show you how to set up a Docker, how to create a container, how we are going to deploy the application, how we are creating our own images, how we are deploying application on top of our images. All these things we are going to see it later, right? We will be jumping into Kubernetes. So we are starting with the customer's requirement. CTS got new project which is in pipeline. They are doing POC for their client requirement. CTS have approached the client in such a way they will help us to move all the VM to a Docker container. By doing this way, they will save the huge cost on every month end. So now client agreed for the proposal. We are going for a demonstrate below things. So everything, right, we are going with the project use case basis. See, there is a manual process in our project which is installing Docker and start the service. Create a Docker file in GitHub repository. Create an image with a Docker file. Deploy the application in the container. Client requested to automate this to Jenkins pipeline. So we'll be taking these kind of real scenario basis thing. Okay, EKS cluster and Kubernetes application and monitoring. My client target, they have a many EKS clusters are running in our environment. They wanted to expose their application via elastic load balancer. Okay, so another one reason why people are migrating to cloud-based Kubernetes, right? In Kubernetes, when you want to expose your application, ELB, elastic load balancer, is the best choice. Actually, load balancer is the best choice. In on-premises, if you want to provision the load balancer, it's a very expensive another device. But in cloud-based Kubernetes, right, in fraction of a second, you can create a load balancer kind of thing. That is the third reason why people are using cloud-based Kubernetes service. Okay, so here we are going with the pipeline based. When you're working in any project, people will be giving the architecture diagram like this only. We'll have to understand this architecture diagram. Even present day, if you go for attending any interviews and all, your interviewer is asking these kind of questions only. Tell me your workflow, how you are deploying your application in Kubernetes. Tell me your behind the screen, what things are going on. What people will do, first in the GitHub light, they will be writing a Docker file things and all. From the GitHub, they will push the code. When they are push the code, Docker Jenkins will take care of it. It will push take the respective Docker file. In the Docker, it will create the image. It will deploy all the application. It will commit the code, and it will it's build the Docker image. It will push it to the ECR kind of repository or somewhere. Using that image, right, we'll be creating our Kubernetes cluster pod. Okay, So this is the things which happening in the behind the screen actually. When you are attending interviews and all, you have to explain them in such a way the entire process. When you will came to know by attending this session, right? So you will be came to know about these specific use case based thing. Okay. So the main ultimate plan, right? This particular batch, I'm not like a YouTubers and Udemy. My main intention, right? I'll be taking this real kind of project based requirement. Okay, everything will going with the architecture based explanation. How we are pushing the image to AWS ECR, how the image has been creating and the cluster how it is getting created. All these things from the real project basis, I'm planning to go. Entire 30 hours of session, right? I plan to include on daily basis one use cases like this after understanding our scenarios. So end of this session, right, you will be familiar with Kubernetes and Docker concept. In addition to that, you will be familiar with real project use cases as well, client requirement as well. So with that knowledge, if you go for attending any interview, right, it will be easy for you to clear it. Okay, somebody, you may have a question now, Hari. I do understand you are going to take a real project-based Kubernetes training. I do understand it. But tell me something, if you are directly taking advanced Kubernetes, these kind of scenarios, how will I understand? I'm very new to Kubernetes and Docker. And what is the pre-requirement to join this particular batch? There is nothing like a pre-requirement, guys. For answering this question, there is nothing like a pre-requirement. It's complete my responsibility, actually. The only pre-requirement is you have to understand my English. Whatever I'm communicating now, right? If you're able to understand my communication, that's the only thing remaining. All my responsibility, I'll take care of it. Why I'm telling this much confident? Whatever pre-requirements are needed, I have included that into my particular session. I'm taking a session from that perspective only. Okay, whatever pre-requirement first 4 to 1 week of session, right? I'll be covering all the pre-requirement and basics. Once you get really confident, then only I'm getting into the advanced Kubernetes. Slowly, day by day, we are increasing the strength of our topic. That is our main motto. Got it? Fine, guys. Hope I'll share this document later, the real project scenario based document. If I'm telling that, right, it will make you overload. So what I did actually, I created a common share drive actually. If I'm sharing this link with you, even you will be able to access this entire drive actually. Okay. So what I will do after this session, mostly I will share this link with you. Okay, go ahead and have a look on it. What is present in this particular drive? You can go over here. You can find there is something called PDF Kubernetes syllabus. Whatever content we are going to take day by day, all these topics and sub-component, everything is present over here. Go ahead and have a look on it. And one more thing, Hari, how can I trust you? Somebody will ask you, sir, somebody will ask me, Hari, how can I trust you? How can I believe you? How you are telling like you are going to take scenario basis training. You are telling like you are going to take everything from the scratch. How can I trust you? For answering this question, right, you can go ahead and refer this particular drive actually. Okay, if you go over here, you can find the people like you whoever attended the session with us before. They have shared their feedback about my training. Here you can find all the people there came into the webcam. They have shared their feedback actually. So not only one people or two people, there are hundreds of people, right, who share their feedback, who share their opinions actually. You go ahead and have a look on it. By the way, you'll came to know how genuine we are, how in depth we'll take the session. Every information you'll came to know about the course. This will give you the more confident. Okay. In addition to that, you wanted to see, Hari, the introduction part you explained very well, but I wanted you to see how we are explaining the technical thing, how we are configuration part and all, how we are explaining. So in this drive, right, in this particular direct demo videos, I kept some of my sessions, whichever I taken recently, right? I've taken few of the videos. You go ahead and you can have the look on it. You'll came to know how I am explaining the technical thing. All these things you'll came to know from this particular drive. Okay. I'll share this link with you. In addition to that, to show more of our genuinity, where are we from, to prove our contact detail, our email IDs, our official website information, how long we are in this industry, and what other services we are providing. Okay, all these things you can get it from what people felt about our training and we are presenting. So, in addition to that, you will came to know about our social media platform, how long we are in the social media platforms, what people have been provided their feedback in our social media platform. Everything, no, you will get it from this particular website. So what I'll do, I'll share both the link actually, this link as well as in the chat box. We have a GoToMeeting chat functionality, right? What I'll do, I'll place both the items. This is something our course detail. You copy the link in your local machine or in your mobile or something like that. Later, right after the session, you go ahead and have a look on it. Okay, I shared both the links. Here you can get all the information. Fine, now what I'll do, I'll just go back to my presentation. I'm going to tell you when this batch is going to start. I already told you this Docker and Kubernetes, both together we are planning to take. This Docker and Kubernetes, I targeted for 1 month training actually. The session will be Monday to Friday, Saturday, Sunday will be pure holiday. The session, right, which is starting from Monday mean not long back, tomorrow, which is starting 22nd November onwards. The training timing will be 8 to 9 p.m. IST. We have only one time slot, 8 to 9 p.m. IST. The timing is 8 to 9 p.m. IST. Now, one more important thing which you all have to keep in mind, this particular batch we are planning to target for 5 to 8 members. In the batch, we'll have a 5 to 8 member. So when 5 to 8 members are joining in the single batch, right? So we can offer the training with huge discount. That is the reason we are planning to provide 75% of discount in our training. So 30% of discount means when you compare my fee structure with outside people, right? Obviously, you came to know the difference. And another reason, people 5 to 8 members in a single batch. From the business perspective, I am also getting benefited. End user like you people, you are also getting training with very less cost with the real project scenarios. That is what individually you are getting benefited. Here, you and me mutually getting benefited. That is the reason end of the day which we are both going to get it. Okay. And another thing, even though you are getting 75% of discount, right? We are planning to provide 500 rupees as an enrollment fees. When you are enrolling into this particular batch for attending the session from tomorrow, you need to pay 500 as an enrollment fees. You can attend Monday session, you can attend Tuesday session, you can attend couple of sessions, right? Then later you can realize it, how quality I am taking the session, how punctual I am. You can analyze my knowledge level, everything you can analyze it. If you really wish to continue, you can proceed further for the next installment of your payment. Otherwise, right, you can first a couple of sessions, you can ask for my refund. Okay, by attending a couple of sessions, if you're really not satisfied, you can ask for the refund. I'll be providing your enrollment fees as a refund. Now I'll tell you what are the actual course fees. When you take Docker and Kubernetes all together, if you go for outside, people are charging up to 18,000 rupees. But here we are giving huge discount. The entire course will still be 7,999. The entire course will still be 7,999. From the 7,999, you are going to pay 500 as a first enrollment fees, first installment fees. This enrollment fees inclusive of your 7,999 only. Okay. Initially, for attending tomorrow's session, you are going to pay 500 as enrollment fees, either through Phone Pay or Google Pay or Paytm or internet banking, credit card, whatever mode of payment is possible, you can do it. So after paying 500 of enrollment fees, you can attend tomorrow's session, you can attend day after tomorrow's session. By analyzing quality of training, you can proceed with the next installment. Is up to you. Okay. This is the details, guys, which I'm continuously talking. What we will do, we'll take a 2 minutes of attention now. Okay. The people whoever are wanted to join the session from tomorrow, so genuinely interested, right? Kindly share your name and contact number in the chat box. We have GoToMeeting, right? We have a chat functionality. You can share your name and contact number. So what I will do, once I receive your name and contact number, after this demo, I'll give you a call back. If you have any doubt or question before getting enrollment, you can clarify your doubt. I can clarify it. After that, I can take you into enrollment. And we have a separate WhatsApp group. From tomorrow onwards, the meeting link will be shared in that specific WhatsApp group only. I'll be adding you once I receive your name and contact number. I don't want your email IDs and all. When you share your WhatsApp number, I'll be adding into my particular WhatsApp group. Okay, from that WhatsApp group only, you'll be getting my contact details. And